Welcome to team number 37's car demonstration. We're going to start by using our key to start the car, and then we can start the engine, which will get the motor running. Can't forget to fasten our seatbelt to quieten our seatbelt protector, and then we're going to cut out and stop the engine to make sure that we can demonstrate the other features of our car. Okay, so we had to comment out the method that moves our car because all the features only run while the engine is running and we don't want our car running around. So we're going to start over the demonstration, but this time the car will not move. So we're going to do the key again and then start the engine or pretend to, which again means we have to fasten our seatbelts. After that, we have our lane detector here, which doesn't do anything as long as it's running on black asphalt. And then if I put something different under it, it'll, like a LED will light up over there and the buzzer will go off. The buzzer is controlled by a semaphore because it's shared with another sensor. And then next we have our servo motor, which acts as our mirror and controlled by this joystick. We can move it around 180 degrees. The LED over here is lit up because our fuel sensor is not sensing any liquid, but once I've put it in some water, as you can see, the LED turns off, and then if I put it out, once it dries off, it will light up again. And as for our rain detector, it will light up when water touches it. Not enough water. There we go. And then again, once it dries off, it will turn off again to tell you that it's no longer raining. And that is all for our car demonstration. Thanks. Hi, I'm Miriam, and my collaboration to the car was predominantly making it move and helping out with the sensors. So in order to make the car move, we had to hook up the DC motors to our H bridges, and in order to do that, we also have to connect the H bridge to the PWM ports on the Arduino board. When we did this with one H bridge, we found that it did not transmit enough energy to the wheels to make everything run evenly, so we decided to split this into two H bridges, which were much more effective for splitting the battery. And then in order to make that work with the code, rather than giving the car the full 255 power, we would write just 127 into each wheel. And then as far as the sensors go, I'm going to tell you about the fuel level sensor, which is an analog sensor, so it does transmit analog data, but we do quantize it in the code to make it so that it can tell you whether your fuel level is high, reasonable, or low. And then the rain detector, which is a digital sensor that simply detects when the water touches it, and then it will light up a LED if there's water touching, and then not light up the LED if water's not touching. So that's a digital actuator for both the rain and the fuel level, which also lights up a LED.
Hello, this is Shannon. I'm going to talk about my part in the embedded systems project. I made the keyless entry and the semaphores for the engine and the key, and I also contributed to making the seatbelt sensor. In order to start the car, the driver first has to unlock it using the tag, hovering it over the RFID sensor, which then detects the value of the tag and compares it to the stored value. And if it's correct, the car unlocks, otherwise it doesn't. Then after that, the driver can start the engine using a button. However, he can only do that if the car is unlocked. When he does that, the car starts moving and all of the other features become available and start working. Also, there is the seatbelt sensor. If the car is running and the seatbelt isn't on, the driver has to press a button which fastens his seatbelt. If it's not fastened, a buzzer will keep beeping until he does so. All of these features were managed using semaphores. Yeah, and that's it.
I'm Khaled, and I worked mainly on our project on lane detection. We achieved that by attaching a sensor to the bottom of our car. This sensor only works when the engine is running. It transmits digital low when the car is moving on a black surface, which is supposed to be asphalt, and it transmits digital high when it moves on any other surface, detecting that the car is moving out of lane. We use these signals to warn the driver that he is going out of lane through two actuators, which are an LED and a buzzer. The LED lights and the buzzer beeps, warning the driver that he is gone out of lane. That's it.
Hi, my name is Yasmin and I'm going to be talking about my part in the Embedded Systems project. I basically worked on two things, the adjustable mirror in two directions, and I also worked on the semaphores and making the car function using the semaphores together. Basically, the car simulates the movement of a mirror by using a servo motor. The servo motor is an actuator that acts by spinning in 180 degrees, and we get it controlled by using a thumb joystick. Some joysticks maps its values into the servo motor and it makes its movements. Secondly of all, I worked on the semaphores. I had 4 semaphores that we use to make the overall project, and we had no global flags. The first semaphore I made was the engine running semaphore, because the engine must start before you do anything else. So we always check if the semaphore is taken before you make movement by the mirror or the lane detection or the seat belt. I also made the car unlocked semaphore, and it works by checking if the car is unlocked before the engine runs. And the seat belt fastened semaphore, it works so that the buzzer buzzes whenever the seat belt is not fastened, so that the driver knows that he should fasten it. And I made the buzzer as a semaphore because it's a shared resource between the lane detector and the seat belt, because they both use the buzzer. So basically the buzzer can only be taken by one of them at a time. Thank you.